So I've seen a lot of students skipping 3D trigonometry question in paper 2 maths. But guys, there is actually no need for you to skip this question because it is one of the very easy questions. So in this video, I'll be showing you step by step what you need to do to get all the full marks in 3D trigonometry. So without wasting time, let's get into it. So before we look at an example, I just want to remind you of the tools that we will need for these kind of questions. So first of all, you need to remember your cosine rule. You need to remember your cosine rule. Remember the cosine rule. If you are given a triangle that is not a right angle triangle, you can use either cosine rule or sine rule. So if this triangle right here that we have, it's A, B, and C, then with the side C, side A, and side B, you can calculate the side A as A squared is equal to B squared plus C squared minus 2BC cosine of A. And also, if you are not able to use the cosine rule for the triangle, which is not a right angle triangle, you can use your sine rule. And remember now, with the sine rule states that A over the sine of A must be equal to B over the sine of B, and it's equal to C over the sine of C. So if you have any time that you're going to have a triangle that is not a right angle triangle, make sure you make use of the cosine rule and the sine rule. When do you use sine rule and when do you use cosine rule? Then I'll make a video on that, then we'll explain that. But now let's look at an example how to apply this in 3D trigonometry. Right. So in this question, this is actually a typical examination question. So in the diagram, PQ is a vertical tower. Why do they say that it's a vertical tower? They say that it's vertical because that will make 90 degrees with horizontal. So this PQ right here, that is a vertical, and you can see that it makes 90 degrees with RQ. Then Q, R, and S points are on the same horizontal plane. Then the angle of elevation R, this angle of elevation R is theta. Then QRS, this angle QRS right here, that is 120 degrees. And we are also given that PQ is equal to RS. So this PQ is equal to RS, which is equal to X. Now, determine QR in terms of X. So I know these questions, they can be overwhelming, but let's break it down one by one. So let's look at the first part here. Determine QR in terms of X. Now, this is exactly the same diagram that we had, but what I have done here, I've highlighted the triangle that you need to be able to determine QR, which is this line right here, in terms of theta. So you see in terms of theta and X. That's why we highlighted that triangle QRP. So to do that, you want to calculate RQ, and you have got X, and that is a right-angled triangle. So every time you've got a right-angled triangle, don't forget to use your SOHCAHTOA. Remember, always use SOHCAHTOA in a right-angled triangle. Nothing else. Don't use cosine rule, don't use sine rule, use SOHCAHTOA. So in this question now, we have got RQ is the adjacent to the angle theta, and X is the opposite. Therefore, we are going to use tan. Then we say now, tan theta equals to opposite. So the opposite is PQ divided by QR, which is the adjacent. And that tan theta is equal to PQ is X over QR. And that's what we want to find. Then we can make QR the subject and we can say QR is equal to X divided by tan theta. And that is how you determine QR in terms of X. That's pretty easy. So you always get such a question. So yeah, that's how you do that QR. Now let's look at the second part of the question. So in this part of the question, we are asked to show that QS, so this is QS right here, show that QS is equal to x square root of 1 over tan squared plus 1 over tan theta plus 1. Now, first of all, you need to identify where is QS and how much information do I have on certain triangles. So here I have highlighted the triangle RSQ because it has a lot of information. There is angle 120 degrees, there is an X, and there is that one. Remember that one that we've calculated, which is RQ from the previous question, which is X divided by tan theta. So don't forget to use that. So now, let's just focus on the triangle RSQ. Now, if you look closely at this triangle RSQ, you can see this is not a right angle triangle, so you're not going to use SOHCAHTOA. And also sometimes this gives you a direction of what you need to do. So if you have got a square root and a lot of squares in the answer that you need to show, you already know that you have to use the cosine rule because it is the one that has got the squared, and also you can make a square root. So in this one, we are going to find the length of SQ. So we're going to use the cosine rule, and we can say now SQ squared is equal to RS squared plus RQ squared minus 2 times RS, then bracket RQ, then times by cos of, so the opposite angle here will be cos of R. Now, we know what RS is, so SQ squared will be equal to RS is x squared, then RQ plus x over tan theta, which we determined in the previous question, but you square that, then minus 2 times x also times by x over tan theta, then cos of 120. Then this can be simplified further to be x squared plus x squared over tan squared theta. And you can see already this is looking like what we want to find, that QS there. Then minus this multiplies x times x squared, then divided by tan theta, then cos of 120. So don't get tempted to simplify here because there is also a cos 120 which is attached to the 2x squared. Even if they look like terms, they are not, because the cos 120 is multiplying the 2x squared over tan 130. Now, after this, we just simplify further, and we will have here x squared plus also x squared divided by tan squared theta minus 2x squared divided by tan theta. And when you simplify cos 120, that will give you a negative half. So times by a negative half. And you can see that these 2 will cancel with that 2, and we just have a positive there. So in the end, we are going to have SQ squared is equal to x squared plus x squared divided by tan squared theta minus, it's actually plus now, remember from the previous, negative times a negative. So x squared divided by tan theta. So then the next step will be just to factor out the x squared there, and you put the square root to make SQ the subject. So then that becomes, so here, SQ squared equals to, so we factor out x squared, then in a bracket, 1 plus 1 over tan squared theta, then plus 1 over tan theta square, bracket squared. So then that will be, so you remove now the square on the SQ by squaring both sides, by square rooting both sides. So SQ will be equal now to the square root of x squared bracket 1 plus 1 over tan squared theta, then plus 1 over tan theta. And this can also be simplified further. Then we can find this, the square root of x squared there, and that will just be x. And then in the end, we're going to have SQ is equal to x, then the square root of this one, we keep it inside the square root, 1 plus 1 over tan squared theta plus 1 over tan theta. And that is how you do this kind of a question. It's pretty easy. If you do it step by step, you always get all the 4 marks. Now let's move on to the last part of the question. Right, in this last question, we are given that if x is equal to 15 centimeters and theta is equal to 22 degrees, calculate QS. So guys, even if you were not able to prove the previous question, it doesn't mean that you need to skip this question, because this is just a simple substitution. So you just use the QS that you have been given from the previous question, which states that QS, remember, was equal to x, the square root of 1 over tan squared theta plus 1 over tan theta plus 1. So this is just a simple substitution. So you just substitute in the values of x, which is 15, then the square root of 1 divided by tan squared theta is 22 degrees, then plus 1 over tan 22, then plus 1. And then just simply punch in your calculator. Don't skip these questions. And this now, you can get the line QS to be equal to 46.48 centimeters. And that is how you do that one, the QS. Now that we have the value of QS, we are also asked to find the angle QPS. And this is the angle QPS. And I also have highlighted with a pink triangle. So always make sure you highlight your triangles. And you can see already that the triangle QPS is a right angle triangle. So the moment you will see that it is a right angle triangle, remember to use your trig ratios. So now we have the side QS, we have determined that, and this is the side QS, which is now 46.48 centimeters. And we also have this side X, and we are told that X is 15 centimeters. Remember, they told us here, always go back to the instructions. So that is 15 centimeters. So if you look at this pink triangle, we have got the side PQ, 15 centimeters, and QS as 46.46, and we want to find angle P. And you can see this is the QS is the opposite, and PQ is the adjacent. Then we are going to use the tan. So tan P will be equal to opposite, which is 46.48 divided by adjacent, which is 15. And you remember that we can find P by saying P is equal to the tan inverse of 46.48 divided by 15. And that will give you 72.11 degrees. And that is how you answer 3D trigonometry. So it is quite easy. Make sure you identify right angles, and if you don't have a right angle, make sure you make use of the cosine rule and the sine rule. See you in the next video. Bye.